This is lesson 2.3. Solve a formula for a specific variable. Our learning objectives are to solve a formula for a specific variable and then use formulas to solve geometry applications. All right, so let's define formula solving. To solve a formula means to isolate a variable on one side of the equation with a coefficient of 1. Everything else goes to the other side of the equation. In example 2.28, we see the volume formula for a cone. Volume equals 1/3 times pi times the radius squared times height. Okay, so they tell me to solve for the height, h, instead of solving for v. Currently, this equation is solved for v, meaning we got it all alone and it has a coefficient of 1. Well, we need to get h alone, so let's rearrange this formula. First, I would multiply by the reciprocal of 1/3, which is 3 over 1. Dividing by a fraction is the same thing as multiplying by its reciprocal. So we end up with 3 times v equals pi times the radius squared times h. At this point, I would divide pi times the radius squared from the right side to the left side. Since pi and the radius squared were both multiplying the height h, well, we could divide them to the other side. Now, we see things cancel, like pi r squared fights and dies with pi r squared. In the end, we got h alone. So h, which is what we were trying to solve the formula for, equals 3 times v divided by pi times the radius squared. And we're done. Let's try another. Here's example 2.29. It says solve the formula for f. So currently the formula is solved for c, and we need to solve it for f. This formula is the conversion formula to turn something from degrees Celsius to degrees Fahrenheit. So it's a temperature conversion formula. Well, let's start. And first I see the fraction 5/9. Dividing by a fraction is the same thing as multiplying by its reciprocal. So I'm going to multiply both sides of this equation by the reciprocal of 5/9, which is 9/5. All right, now the cool thing is that the 9/5 kills the 5/9 on the right-hand side of the equal sign. They cancel each other. So rewriting the whole equation, I have 9/5 times c equals f minus 32. The last thing to get the variable f by itself is add 32 from right to left. So now I have something that says 9/5 times c plus 32 equals f. All right, we have solved for the degrees in Fahrenheit. Next, example 2.30. Solve the formula that you see for h. This is a surface area formula. All right, so it's currently solved for s. We want to solve it for h. Well, any terms that don't have h in them, we can move to the other side of the equal sign. For example, this term right here does not have h in it, so I'm going to subtract it from the right-hand side to the left-hand side of the equation. Let's do it. Okay, we'll rewrite everything. S minus 2 pi r squared equals 2 pi r h. Next, since we're trying to solve for h, and 2 and pi and r are all multiplying it, we could divide to the other side. 2 times pi times r. We see that these cancel. We have now gotten h all by itself. So h is s minus 2 times pi times r squared divided by 2 times pi times r. Great. And here's example 2.31. Solve the formula for y. All right. Well, this formula is not currently solved for any variables. So 15 is by itself. We need to get y by itself. Well, like we said in the last problem, we want to get any term that doesn't have y in it to the other side of the equal sign first. So I would subtract 8x from left to right. 7y equals 15 minus 8x. Next, I would divide 7 since it's multiplying y. We find out that y is equal to 15 minus 8x divided by 7. We did it. We have solved for a specific variable in this formula. Great. Let's move on to our next learning objective. Our next learning objective is to use formulas to solve geometry applications. These are real-world problems, so the 7-step process that you see here may sound familiar from our last lesson. Okay, so how to solve geometry applications. Step 1, read the problem. Be sure all words and ideas are understood. Step 2, identify what you are looking for. Step 3, choose a variable to represent what you are looking for. Draw the figure, label it with given information. Step 4, translate into an equation by writing the appropriate formula. Substitute in given information. Step 5, solve the equation using good algebra techniques. Step 6, check the answer in the problem and make sure it makes sense. And step 7, answer the question with a complete sentence. Great, this is a familiar step process, slightly different from before because now we're dealing with geometry applications. So we'll be drawing, our geometric shape and labeling it with essential information. So what are some of the shapes that we'll be encountering in this course? Well, here are 4 two-dimensional shapes: the square, rectangle, circle, and triangle. All right, so let's talk about a square. I've created a little diagram on the side here to help you. Now, the variables that we deal with when we're talking about squares, we call a side length of a square S for side. So here's S, it's the side length of this square. Now, if we're talking about its perimeter, then it's 4 times S because there are 4 side lengths added together. They are equal, so 4 times S. And if you want to find the area of the square, you multiply the side length times the side length, right? S times S, that's S squared. So you need to know the perimeter and area formula of a square. Let's now talk about a rectangle. Now, the variables in a rectangle are the length, L, and the width, W. Here's a diagram showing it. So we've got the length and the width of a rectangle. It really doesn't matter how you write them. You could put the width here and the length here. It doesn't matter at all. Now, moving forward, we see a formula for the perimeter. The perimeter is 2 times the length plus 2 times the width. The reason being that, you've got 2 lengths and 2 widths when you look at a rectangle. And so if you multiply 2 times the length plus 2 times the width, that will give you the total perimeter of that triangle. Moving forward, to find the area of that rectangle, you would simply multiply the length times the width. So just multiply these dimensions together. Let's talk about a circle. A variable in a circle is the radius, r. And so here is a circle diagram, and our radius is the distance from the center of the circle to a point on the circle. That's the radius length. Now the radius helps us find the perimeter and area of a circle. The perimeter of a circle is called a circumference, so that's why we're using c instead of p. It's called the circumference. We take 2 times pi times the radius to find the circumference. And the area of a circle is found by taking pi times the radius squared. Lastly, let's look at a triangle. A triangle has side lengths A, B, and C. As shown in this diagram here, we've got side length A, side length B, and side length C. Now, the base of the triangle is the bottom of it if we lay it sideways. So it's called B. And the height of the triangle is the distance from top to bottom. The height is this vertical distance here. It's denoted H. To find the perimeter of a triangle, we add the side lengths together. So A plus B plus C. To find the area of a triangle, its formula is 1/2 times base times height. So we take 1/2, multiply the base, and then multiply the height. Now, I'm going to erase these diagrams except for the triangle because our first problem has to do with triangles. So I'm going to move this over here. And it says the area of a triangular painting is 126 square inches. The base is 18 inches. What is the height? So let's address what we know. Okay, we know the area is 126, right? So we know the area is 126, and we know what the base is. It's 18 inches. What is the height? Now, you'll also recall from our formulas up above that area equals 1/2 times base times height. Since the area equals 126, I can replace A with 126. Now, I also know that the base is 18 inches, so I can replace base with 18. Now I know everything in this equation except for h, the height of the triangle, and so now I can solve for the height if I divide 1/2 times 18. Remember, dividing by a fraction is the same thing as multiplying by its reciprocal, so I'm going to multiply by 2 over 1. And I can divide 18 from one side to the other. So if I take 2 times 126 and divide by 18, I find my height. It's 14 inches. Okay, you'll see to answer this question, I first created a diagram. I then found critical information, like I knew the inside of this triangle, its total area was 126, and its base was given as 18. So it's good to replace the things that you know from the variables, right? So get rid of the variables, put in the things that you know, and then use these formulas to help you answer questions. Right? These formulas up above for these 4 shapes. Now, to help us in this next problem, we have to talk about the sum of angles in a triangle. Now, a triangle's angles, their interior angles will always add to 180 degrees. Okay, so we can take, let's discuss that. Let's take a triangle, and we can make this triangle any triangle shape we want to. Let's make it nice straight lines. Well, the angles on the inside of a triangle, there are 3 of them. So let's call this angle A. Let's call this angle B, and this angle C. And so this formula, this definition says if we add up all the angles in a triangle, it will always equal 180 degrees. This is important to know so that we can answer some problems that come up. For example, 2.33 says, the measure of one angle of a right triangle is 40 degrees more than the measure of the smallest angle. Find the measures of all 3 angles. All right, so I'm going to draw a new diagram. They told me this is a right triangle. A right triangle is one that has a 90-degree angle in it. And we put a little square in the corner to show that that's a 90-degree angle. This is a right triangle. Okay, so we know that this angle right here is 90 degrees. Now we've got 2 remaining angles to discuss. And one of those 2 remaining angles is 40 degrees more than the measure of the smallest angle. So if this is the smallest angle here, then let's call it x. And then this angle that's remaining would be 40 more than the smallest angle. Now I have enough information that I know to create an equation that allows me to solve for x. Okay, so that's our next step. We know that all three angles added together, x plus 40 plus 90, has to equal 180 degrees. Okay, so that's the smallest angle, the next mediumest angle, and the 90-degree right angle added together. They have to equal 180 degrees. Now that we've written this equation, we can combine like terms. So 1x plus 1x, right? I could take this x, and I can add them together to make 2x. And I could take this plus 40 and this plus 90 and add them together to make 130. And that equals 180. So we've now simplified this equation by combining like terms. Now let's do a little more algebra. We have to subtract 130 from left to right. And we will rewrite this as 2x, let's do that in blue, 2x equals 180 minus 130, which is 50. So I've rewritten my equation. It now looks much simpler. I now divide by 2, and I find out that x equals 25. Well, let's give this some context. 25 what? Well, 25 degrees. We've just found the smallest angle in this triangle. Let's go ahead and write it in. We know that this angle in this bottom right corner is 25 degrees. But now that I know that, I can find the next angle larger because, well, it's x plus 40. So x plus 40, well, that's going to be 25 plus 40 because we know x is 25. So 25 plus 40 gives us 65. So the next larger angle is 65 degrees. So I'm going to just get rid of x plus 40 and say, well, that's 65 degrees. I have now found all three angles of my right triangle, 25 degrees, 65 degrees, and 90 degrees. Moving on, let's talk about the Pythagorean theorem. It's an important theorem for triangles. In any right triangle, like the right triangle we just discussed, where A and B are the lengths of the legs and C is the length of the hypotenuse, the sum of the squares of the lengths of the two legs equals the square of the length of the hypotenuse. In other words, a squared plus b squared equals c squared. All right, so let's break that down. Let's take a right triangle. Now, the hypotenuse is the longest side, and the 90-degree angle always opens up to it. The hypotenuse must be called c. The other two are the shorter legs of the hypotenuse, and they're called A and B. All right. So the Pythagorean theorem says that if I take A and square it, and I add it with B and square it, it must equal C that is squared. All right. And this is always true for a right triangle. It's a theorem. This Pythagorean theorem is named after Pythagoras, a Greek mathematician and philosopher. So it's named in honor of Pythagoras. He had a group of triangle worshippers, and they learned lots about triangles over time. Okay, well, let's use the Pythagorean theorem to find the length of a leg of a right triangle if the other leg is 12 and the hypotenuse is 13. So let's use this right triangle we've already built. And they told me the hypotenuse is 13. So that's C, the longest side length, which the 90-degree angle opens up to. And then the other leg that we know is 12. Let's just pick A or B. It doesn't matter which one we choose. So we'll make B become 12. Now they want me to find the length of side length A in this right triangle. So I'm going to use the Pythagorean theorem now. So let's use this formula. So I'll say A squared plus 12 squared equals 13 squared, like that. All right, now I can solve for A. Let's do it. So to do it, first I would subtract 12 squared from the left-hand side to the right-hand side. I can now rewrite everything as A squared equals 13 squared, which is a perfect square, 169, minus 12 squared, which is also a perfect square, 144. Next, to undo squaring, we can square root. So we're going to square root both sides. And 169 minus 144 is 25. So I'll just erase that and put 25 first before I continue. 169 minus 144 is 25. So I square root 25, and I'm actually really kind of excited because 25 is a perfect square. So the square root of a squared cancels, right? The square root and the square cancel each other. I'm left with just a, and the square root of 25 is just 5. This is our solution. So we now know that this unknown side length, a, is really 5. So I replace it. Moving forward, we have example 2.35. The length of a rectangle is 6 centimeters more than twice the width. The perimeter is 96 centimeters. Find the length and the width. All right, let's create a diagram of a rectangle, right? So we're given the shape in question. It's time to create a diagram. Almost there. There's a rectangle. All right, so let's say this is the length and this is the width. Let's go ahead and read the information, right? The length is 6 centimeters more than twice the width. So if we call this the width and this the length, well, the length can be compared to the width. And so the expression that we can create is 2 times the width plus 6. So I just replaced the length with 2 times the width plus 6, what it's equal to. Now that I've done that, I can use the perimeter formula. Because they told me the perimeter is 96 centimeters, I'll get out the perimeter formula for a rectangle, which is perimeter equals 2 times the length plus the width. Now, remember, we just said the length can be written as 2w plus 6. So let's go ahead and write 2 times, well, the length, which is 2w plus 6, and then plus w. So what did we just do? We just replaced the length with 2w plus 6, because that's what they said it was. And we can also replace the perimeter P with 96 centimeters, because we know the perimeter is 96 centimeters. I now have an equation that says 96 equals 2 times 2w plus 6 plus w. We can simplify this equation that we've created to solve for the width. I'll do it for you. So cleaning this up, I get 96 equals 2 times, well, 3w plus 6. Then I can distribute this 2 into both of these terms. I'm going to rewrite it. 96 equals 6w plus 12. Now, think of the two basic operations you can do to get w alone. You have to subtract 12. I'll write the result here on the left-hand side. So 96 minus 12, 84. And that's equal to now 6w. This stuff canceled. Now, divide by 6. And we find out that W, the width, is equal to 84 divided by 6, which is 14. All right, and that's centimeters, right? We've been talking about the length in centimeters. Now, we found the width, but we still have to find the length. So we can take the width information and plug it in to this expression, right? The length is equal to 2 times W, which we found to be 14 plus 6. And that's 28 plus 6, which gives me 34 centimeters. Okay, so my length is equal to 34 centimeters. I have found both the length and the width. Let's try another. Example 2.36 says, one side of a triangle is 3 inches more than the first side. The third side is 2 inches more than twice the first. The perimeter is 29 inches. Find the length of the 3 sides of the triangle. To begin, let's draw a diagram. And we can just draw a general triangle diagram. We don't have to be completely accurate with its lengths. Okay, so there's a triangle for us. And now let's break this down sentence by sentence. It says one side of a triangle is 3 inches more than the first side. All right, so let's just call the first side X. Well, then the next side, that side they're talking about, is going to be X plus 3. It's 3 inches more than the first side. So just start by calling the first side the variable X, then the next side X plus 3. Now let's think about that third side. The third side is 2 inches more than twice the first. Okay, so it will be 2 times the first side length plus 2, because it's 2 more than that. Now that we have written all 3 side lengths as expressions with the variable x in them, they tell me that the perimeter is 29 inches. Now recall, the perimeter formula of a triangle is perimeter equals, well, the first side length plus the second side length plus the third side length. Let's input everything we know into this formula. Well, the perimeter, they told me, was 29, so P becomes 29. Let's call A the first side. Well, that was what we called X. B is the second side. That will be X plus 3. And C is the third side. That will be 2X plus 2. Let's go ahead and combine any like terms that we can on the right-hand side of the equation. So I see X plus 2X. So I'm going to rewrite that as 4X, combining those like terms. Now I see plus 3 and a plus 2. Everything here was summed, so I'm just adding the pieces together. So those constants we saw, 3 and 2, become 5. All right, this looks easier. Now, there are 2 basic operations to do to finish. To solve for x, we just need to subtract 5 and then divide 4. Let's subtract 5 first. 29 minus 5 gives me 24, and that equals 4x. And now we can divide by 4 on both sides, and we find out x equals 24 divided by 4, which is 6. And we are talking about inches as our length in this case, our unit of length. So I'm going to write x equals 6 inches. I've just discovered the first side of the triangle is 6. But they want me to find the length of the 3 sides of the triangle. So I can plug 6, x equals 6, into this spot for x and this spot for x to find the other side lengths. For example, I take 6 plus 3 to get 9, so this side length is 9. And then I would take 2 times 6 plus 2 to get this last side length, which is 14. Great. We have found the 3 side lengths of the triangle. those three side lengths, the first side was 6, the second side was 9, the third side was 14. Example 2.37. The perimeter of a rectangular soccer field is 360 feet. The length is 40 feet more than the width. Find the length and the width. Let's begin by drawing a diagram again. So we know we're dealing with a rectangle. The diagram for a rectangle is drawn. Now, there's a comparison of the length with the width. The length is 40 feet more than the width. So if we call this the width here, and this the length, well, we can replace the length L with W plus 40. The length is 40 more than the width. Now, they tell me what the perimeter of this rectangle is. It's 360 feet. So I'll get out the perimeter formula for a rectangle. Perimeter equals 2 times length plus the width. All right, let's replace the things that we know. Like perimeter, well, we know the perimeter is 360, so P is 360. Equals 2 times the length. But we wrote an expression for the length in terms of the width as W plus 40. And then I can add W, the width. Writing it like this allows me to solve for the width. So now let's get out our algebra skills. First, rewrite the equation combining any like terms. For example, W plus W is 2W. Next, distribute 2 into both of these terms. Next, there are 2 operations to complete to finish this. The first is to subtract 80. 360 minus 80 is 280, and that equals 4 times the width. Now, divide 4 from right to left. We now know that the width is equal to 70. Well, 70 what? 70 feet. Feet is the unit of measurement that we're using. So now that we know the width, W, we can find the length by inputting it for the width here. Okay, so the length will equal the width, which we now know is 70, plus 40, which is 110 feet. Okay, so there we have found the length. Here's our final example for this lesson. Example 2.38. Kelvin is building a gazebo and wants to brace each corner by placing a 10-inch piece of wood diagonally as shown. How far from the corner should he fasten the wood if he wants the distances from the corner to be equal? Approximate to the nearest tenth of an inch. So let's focus on this little piece that he wants to build. Okay, so it's this little corner right here that we're talking about there. Okay, let's even zoom in on it even more. So I'll create a diagram that's larger of this piece. And so here I'm just enlarging that piece that we're looking at. It's a right triangle. Okay, so there we go. And we know that the hypotenuse is 10 inches. So it's saying that this piece from here to here is the hypotenuse. It's 10 inches long. And he wants to know how far from the corner he should fasten the wood if he wants the distances from the corner to be equal. So he wants these two distances equal, and we need to know how far that is. That's the thing in question. Let's call it x. All right, so we can use the Pythagorean theorem to answer this question, right? Like a squared plus b squared equals c squared, because this is a right triangle. So the short sides of this right triangle are x. So we can say x squared plus another x squared equals 10 squared. Well, 1x squared plus 1x squared is 2x squared. These are like terms that can be combined together. So I'm combining like terms, okay? And 10 squared is 100. Now, a little algebra. I'm going to divide by 2 and find that x squared equals 50. And how do you undo squaring the variable x? Well, the opposite of squaring is square rooting. So we're going to square root both sides of the equation. So we get a cancellation of the square root and the square. Okay, once again, the square root and the square, they cancel each other. That's why we can just say the answer is for x, right? We don't want to solve for x squared, we want to solve for x. And it's equal to the square root of 50. Now, the square root of 50 is a number that goes on forever, and it's approximately 7.1 inches. So go ahead and practice square rooting 50 in your calculator and finding the decimal approximation. They wanted me to round to the nearest tenth of an inch. Okay, that's one decimal place, and we have our answer. Well, we've gone through quite a few examples. From the beginning, looking at this, we talked about solving a formula for a specific variable. Okay, we did 4 examples, and we increased the complexity little by little, making sure that you were comfortable. Next, we looked at 4 critical two-dimensional shapes: a square, rectangle, circle, and triangle. And we answered a lot of geometry applications with those shapes. We talked about rectangles, we talked about triangles, we talked about squares. Okay, so great job. Thank you, and I hope you have a great day.